In this part we are going to assemble the base of wooden haptics, and I'm also going to introduce a number of tools that we need and that are very useful. So first of all, here are all the parts, and these parts are only for the base body that we are gonna assemble first. And it's a very good practice to sort out so that we only have those parts that belong to this body present at the assembly. Otherwise it would be overwhelming with all the parts. So either if these come in a plastic bag, that's preferable, or otherwise if you order the parts individually, you look at the bill of materials and sort out those parts that we need for this base. So also introducing the tools. First of all, it's not strictly necessary but very much recommended to have a caliper, and this is a rather cheap one, but with a digital display makes it very easy to figure out what diameter and length there are of a screw, for example. So we can see here this is a 3mm screw, and it is 35mm long. Also as a note, we always use the metric system, except in exceptional case. What more? Well, the screws are these socket head cap screws, and the socket is this Allen key or hex key, or some even known it as IKEA key, of various sizes though. So we have one that fits perfectly with these 3mm screws, M3 screws that would be. We have another one that fits with these larger screws, and we have a tiny one that fits with our flexible coupler. This is a very special part. It's quite expensive, but it is very nice that we can attach it to the motor that we're gonna do later, and then on the other end we're gonna attach the capstan, and it is flexible a bit. So although we are using very precise assembly techniques, there will always be some very slight misalignment, and this one takes care of that. So I should have screwed this tighter if I wanted to stay. It also allows for easy replacement of motors, so if you want to experiment with different sizes and so, you can just decouple here and replace it. We're going to put the motor aside for now. Whoops. And that. And we are going to start with the base of the base. Okay, so I'm going to put all these to the side. And now we're going to look at these 4 base plates that we have. And one thing to note is that, of course, these are a bit different. So how do you know where to put them? Well, you look at the CAD model. And for that, now when we're using Onshape, you can view them in any web browser and also on your tablet. So here I can see the full model of the base assembly. And we can also look at the individual parts, I think. We should hide other parts here. So we find that this is the base with the very bottom of the plate, and these ones are, you can place them on either side. You see that the cutting process makes it a bit more burnt on one side than the other, so you can basically choose. Also in the laser cutting process, the beam will be a bit like cone shaped, so the holes would actually be a little bit larger on one side than the other, and that can also be used in the assembly process. I don't think we need to worry in this case. They are quite straight. So yeah, we have that there. We're gonna look here at the different types of holes that we have here. So first of all, we have these screw holes, and if we put these together, we can see that we can also measure this dimension. Each plate should be 6 mm about, and together here they are 24. So that should be correct, right? 6 times 4 is 24. Okay, so we should use these grooves. You can also look at the bill of materials, or the CAD model actually. But we can also hold it up like this and see that it makes sense, right? That this one should attach in the bottom plate. And the holes work like that, that there are different types of holes. First there are through holes. So those through holes let the screw go very easily, just straight through, okay? So we can see that this plate actually was the bottom plate, because it doesn't go straight through. Here it goes straight through, and here it goes straight through. So actually here there's no attachment really between these ones. It actually attach only to the bottom plate, and as you screw this tight, these all will be pushed together basically with this one and this one. So if you look very carefully or measure, these holes are larger than this hole, okay? Then we have these holes that are just straightly the same size, and they are all 3 mm holes. We have that here, here, and here. Yeah, you can also measure them to see this. So this one is, right, if I measure it here, it's like 3.05 or 3.1, it depends a little bit. This one is smaller, it's 2.3, 2.5, something like that. It should be 2.5, no? What we use these holes for is for the dowel pins, and these are these ones, and they are inserted, and their purpose is to align the plates together, so we have perfect alignment. They are much more precision in their size, and they are press fit here. They shouldn't be just going straight through. Here it actually does. So you normally have to push them through here, and that actually aligns the plates together. So in more professional mechanical engineering, you don't use screws for alignment. You use double pins for alignment, and then you use screws for tightening the plates together. So each part has its own purpose. Okay. So how to insert the plates? Insert the pins. We use this machine, and it's called arbor press. In Swedish, it's called verkstadspress. Took me a while to find the right translation for that. So there you have it, verkstadspress. And what it does, it's pretty simple machine. You just push it down, and this goes with a quite high force as you turn, pushing it very straight. So the problem if you would use a hammer or something is that you might tilt it and so on. This one goes very straight up and down. It also makes it for a quick assembly, and these are quite cheap, so just suggest you buy one. Okay, so I'm gonna start here by inserting one of the pins here. You see it can comes out here. One trick, I mean, you can do it differently, but is to push it through a little bit with one of these holes here, so it comes out a little bit on the other side. You can take the next plate, so it goes a little bit in before you go through again, and these ones are actually a little bit short, but they works for this. So we have there. So since it's a little bit short there, we can actually insert from the other side for this. So I'm gonna just do it. And again here, to know which holes you should use, you can carefully look at the size of the hole here on the bottom plate, where we know that the screw holes that go straight through a little bit smaller. But the best is of course to look at the CAD model again, back and forth. Maybe easier to have a laptop and a physical mouse to look up these things. Okay, so where were we? Well, okay, we have attached, inserted the pins, and now we're gonna insert or screw this together basically. So again we have to look where is this is the bottom, this is the top. Insert all these screws there where they should be, and for that of course can be good to look at the model. So see here that we should have it around. I have it the same way, you can see. Okay, and now we take our IKEA key and just screw them. Alright. So here it is actually often enough to just use the short side of the hex key to turn. I can move this quite ugly machine and okay, now we're gonna add the tower of it. It's pretty straightforward, so you can look at these again. These parts are the same. This one goes on top, and here we see we also have smaller and larger holes. Here we have also smaller and larger, and the smallest hole here should be aligned with the larger hole here. And why is that? Well, these are the through holes. Again, these ones are the holes that are always the same, pinholes. So it's gonna go like that, because we're gonna attach the screw there, and we're gonna use pins straight through there. So here we need a little bit longer screw, or longer pin. You can see, goes straight through there. So there's one pinhole. So I'm gonna go that with the machine. Can actually that one loose. No, I can use pleats. Push them back. And also when you push, be careful, because you want it to be to align itself. Don't use force, because then you will make a larger hole. You don't want to do that. You want it to be carefully inserted, and the plates will align along the way. Okay, so here we have a pin, there we have a screw, pin, screw, pin, screw, pin, screw, pin, screw, pin, screw. Okay. It can actually be a little bit overkill with these many pins here, but when we start this project, we follow the principle of first you use maybe too much, and at a later point you could reduce. So if you feel that we used way too many pins here, it's actually not necessary in order to align the plates. Well, feel free to modify the design and remove, or maybe not even insert them. Okay, this one was actually tricky to get in. How would you do that? You can't really do that, right? So we have to use the sheet way, which is the less preferred way. You easily just insert them like this. Okay. I don't really like that. I mean, this is not the way to really do it. You can get larger arbor presses, and that is much more preferred. Or we can, for these pins, maybe even skip them. Alright, screws. I look from behind here. So here's quite obvious where the screws go. So we have made these holes here to avoid having sockets that go up on the base. So the base is supposed to be flat, right? Then how long should these screws be? Well, you can look again at should probably have this one, but maybe we should take the time and look at the part here, and it actually says M3 times 35, and we're gonna look, and this one is, let's actually measure it like that, 35. Sorry, didn't show that, so I just double checked here that we're using the 35 millimeter screw there. It can also look like that it might even look a bit short here, but oh, actually, because it's not attaching to this, it's actually attaching to that blade, and it is perfect length. So now we're gonna build this tower of sorts. We have these plates that just build up like that, and on top we have these three, and we have to look carefully at these, that they are different. They're two of the same size or hole dimensions, and there's one that is smaller. That one should be in the middle. And there we're also gonna insert bearings. So first we're gonna align these. So I'm gonna align them with these pins that we have here, and they were, this one you could almost use without machines. It's just a hint that there are bits, the holes are a bit too large here, but that would be, it's okay, it's perfectly okay. We have the bearing that's going here, and another bearing here, and we're gonna use the arbor press again, but we don't really want to push straight to on here, so we have a little part. So basically we're gonna use another part in between here, just as a way to not hurt the bearing. Okay, so that nice straight goes in there. The other one as well. Okay. Now we're gonna touch these. I'm gonna touch this from the other side. So those two are there. Rest of the tower comes here. So it should stand like this. Before I touch them, I'm gonna screw these together. And as you can see here, this thing might be just too short, too long. So we are shortening it by attaching a spacer of 1 millimeter, and it's a easy way to make a screw shorter. Starting these here, then here. See, maybe should have added another one. We're gonna put feet on this later too, so another of these could be fine. It depends a little bit how exact thick the plywood sheets are. So if they are a little bit smaller than 6 millimeter, maybe you need to add another spacer. But okay, let's continue. The rest is obviously this, and then eventually this that we're gonna attach to the motor. So we could actually do this first. Take the motor, make sure this thing is tightly coupled. Goes in here. Sits there now. Tower. here we can insert pins. That won't go in there either. Okay. So take the motor, think a bit where you want this encoder cable to come out. So not like that, but here. And this is just straight 6 screws. Okay, can't have it perfectly straight back, but you can have it a bit there. Okay, as we see here, we actually remove one of these because our flexible coupler is so short. There are larger ones. We used to have bit larger ones, and sometimes you need that if you have a very big motor. So then you need that. Now we remove one of these. I'm also taking the motor and I'm gonna attach it here because it's the easiest to do it right now. Also insert it a little bit there and touch it. And this thing goes in here. I don't know if you see, yeah. It's pretty straightforward. Everything is as straight as you can. And then we have the final screws here and here. For this it's actually quite good to have a long Allen key and one that with a ball end that you can tilt a bit, so that it's easier to reach. So here we have it.